Dear friends, once again welcome. Let us discuss the problem related to the friction. So the problem statement is two blocks A and B are resting against a wall and the floor as shown in figure. So you can see there are two blocks, block A, block B, and this is the wall, this is the floor, okay, and then find the value of the horizontal force F here applied to the lower block. This is the lower block. This is the lower block that will hold the system in equilibrium. Coefficient of friction are 0.5 at the floor, means floor it is 0.5, 0.3 at the wall it is 0.3, and 0.2 between the blocks. So mu b is equal to 0.2. And what about weight of block A? Weight of block A is given WA 500 Newton and WB it is 1000 Newton. Okay, so what we have to do, let us start our study from the free body diagram, and it is very obvious. So इस क्वेश्चन में what is the statement, what is saying that कि ऐप का वैल्यू क्या होना चाहिए कि ये जो ब्लॉक ए है, अपर ब्लॉक, वो इक्विलिब्रियम में रहे, वो मोशन में नहीं आ जाए. ठीक है. और ये जो बी है, बी उसको ऐसा मीन्स प्रेस करके रखेगा जिससे वो नीचे की ओर मीन्स मूव ना कर पाए. It should not move downward. Okay, so it is the friction related to equilibrium conditions of the systems. So let us solve this, and what we have to do, firstly our focus is block A, and then the free body diagram of block A, F, B, D. Let us draw it. So the wall, so here normal force will be there. Suppose we are giving the name N1, this N1, and it will try to move, this block will try to move downward. So that's why the frictional force upward, frictional force will act upward. So here this is, and it is mu W multiplied by N1. And what about here? You can say there is a air. And what about this side? So it will be perpendicular due to friction between the blocks. There is also friction, and it will act obviously perpendicular. Okay, and the friction will be what will be the direction? Direction will be like that, because it will try to oppose the movement, downward movement of the upper block, means block A. Okay, and what about this direction? Angle. So it here 60 degree. So the this one also 60 degree horizontal, this one, and this is the vertical, and this is what, let us give its name n2. So this will be what, mu, and the blocks, this one ub multiplied by n2. And if you resolve the forces, okay, so it will be what, this angle will be, let us do it, let us extend it here. So this will be what, the same 60 degree with the horizontal. And what about n2 is also inclined? So to find this angle, let us extend this, and here also we can, if we don't extend, then also from here, yeah, so this angle is 60. And what about this angle? So this angle is 90, this angle, then this will be 30 degree. Okay, so what about this angle? Means vertical, it will make 60 degree. So it is the free body diagram of block A. And weight also we have to show. And what is the value of weight here? So it is 500 Newton. Okay, so how many forces are there? So there are 5 forces. How many forces? So 5. How many forces are acting on block A? So firstly n1, then mu w n1 frictional force means second, and the weight of block A third, then n2, then mu b and 2. But we know the value of this frictional, means coefficient of friction. So how many unknowns are there? So n1 and 2, these 2 unknowns are there. Okay, so now let us satisfy the equilibrium conditions. So we are doing this summation of fx is equal to 0, then n1 direction positive, and what about n2 direction? So n2 is negative. Okay, and it is with the sine 60 degree, because it is making angle with the vertical. Okay, but we want the, means a horizontal force. This one we want, means this we want, this we want. Okay, and what about the frictional force? So frictional force, and it is acting here, the direction is, so it will be what, the direction is positive, you can see here. So it is mu b and 2, and it is making 60 degree with the horizontal, that's why cos 60 degree is equal to 0. And this can be simplified. How? So n1 minus n2 is common, n2 sine 60 degree plus mu b cos 60 degree is equal to 0. So what we get, n1 minus n2, then sine 60 means 0.866 plus mu b is here, what, mu b we can see here, mu b 0.2, and cos 60 means 0.5 is equal to 0. So what we get ultimately, and one thing we are forgetting, because common we have taken, so what will be, this will be with minus sign, minus here, minus here, minus. So what we get, n1 minus 0.766 n2, and it is equal to 0. So this is our first equation. Okay, and what about if we satisfy the equilibrium condition in y direction? So let us do it here, so that we can take the reference of figure. Okay, so summation of f y is equal to 0, and see here, mu w n1 acting upward, the weight is acting downward, and what about this n2? So n2 vertical we have to take, and it is acting upward, n2 cos 60 degree. And what about the frictional force? So that is also acting in upward direction, so n2. And what about its angle? So it is making, means what will be, it will be making 60 degree with the horizontal, so that's why sine 60 degree. Okay, so what we get after simplifying this, we get mu w n1 and plus here it is n2 taking common, so cos 60 degree plus mu b sine 60 degree, and it is equal to 500. So by simplifying this, what we get n1 plus 2.2 n2 is equal to 166.7. So this is our equation number 2. Okay, and what we have to do now from equation 1 and 2, so we are equation 2 minus equation 1. Okay, so what we get here, and this is the equation number 1, this is equation number 2, so we get here n2 is equal to 166.7 divided by 2966 is equal to 562 Newton we get. Okay, this is the answer of n2. Okay, so it is our n2. And from here, can we get n1? So definitely we can get n1 by putting n2 in equation 1. Then it will be what? n2 here we got, and n1 so from equation 1 we can get, from equation 1 we get what? So it is n1 is equal to 0.766 n2, and 0.766 n2 is what here? 562 Newton. So it is equal to 435.5 Newton. Okay, so what we got N1 and N2, and what about, actually we have to get P, means a force F, we have to get it. So let us draw the free body diagram of block B. And better if we have started from the block B, so that we could know what are the things required to be calculated, but it's okay. Okay, now FBD of block B. So it is so in this way it is a block B. Its weightage here 1000 Newton, and yeah, F ejecting. And what about here the friction? So, and what about the direction of friction here? So it is this one. And what about this one? So let us take it N3, N3, and this is then floor mu F N3. And what about here at this? So with the help of block diagram A, so this N2 now in opposite direction. So N2 is in opposite direction but perpendicular to this plane N2, and just opposite to the direction we have to take the frictional force. It is acting upward in the block A, but here we have to take in the downward direction. Okay, so it is what then mu between block, friction between block and N2. So in this way we have done it, and this angle is 60 degree. Okay, so obviously this angle will be 60 degree. And what about this? If you resolve this, so this is vertical and horizontal, so it will make this vertical, this reaction, this N2 with 60 degree. Okay, so in this way we have done the FBD we have drawn. Now let us satisfy the equilibrium conditions. So summation of Fx is equal to 0. Then see the force direction F with minus, and the frictional force, this one mu F multiplied by N3, and what about this one, this force? So it is acting in negative direction, so mu B dot N2, and what about then this one? So it is N2, and what about the sin means we're taking horizontal component of this, so horizontal component will be what? It is cos 60 plus N3, yeah, sorry, not this one, I forgot, is equal to is equal to 0 there will be. Okay, so from here n3 we need to find out then what is n3, n2 we have. So let us satisfy this equation number third. Okay, now satisfying equation of summation of Fy is equal to 0 and it is equal to this n3 is acting in upward direction, so with positive, and the weight of the block in the downward direction, so negative, and the frictional force at the block between the blocks. Okay, so it is acting in downward direction. This is between the block, this we have to take. Okay, so it is n2 sine 60 degree, and then the next one, this n2 also we have to take. So, and it is acting in downward direction, n2 vertical, it is making 60 degree, so that's why cos 60 degree is equal to 0. And let us simplify it. So n3 minus here n2 we're taking common, so it becomes mu b sine 60 degree, and it will be plus cos 60 degree, and it is equal to 1000. Okay, and this n2 is what we know, that n3 minus n2, and mu b is what? Mu b is here 0.2, and sine 60 it is 0.866 plus cos 60 0.5 is equal to 1000. Okay, so n3 minus what we get after 0.67 n2 is equal to 1000, and this is the fourth equation. Okay, so what about n2? So n2 already we have from here 560, this one 562, n2 is equal to, we have from calculation we know n2 is equal to 562 Newton. So let us put this in equation 4. So we get n3 is equal to 1000 minus, it will be plus. So what we get, ultimately we get 0.67 and 562. So n3 we get here 1376.5 Newton. Okay, so coming back to our equation number third. So from equation third, what we have? So this F is equal to mu F multiplied by n3 and minus mu B multiplied by n2 cos 60 degree, and mu F what we have. So this mu F we have 0.25, and n3 we have 1376.5, and this mu B we have 0.2, it is given, and n2 this one 562, and cos 60 it is 0.5. So ultimately what we get? We get 86.367 Newton. So this is the minimum force required to keep in balance in equilibrium. So F is equal to 86.367 Newton. Force is required to keep equilibrium to the system. So in this way we have done it. And let's once again summarizing this. You have to always remember here whether the frictional force will be acting upward or the lower direction. So depending upon the situation, यहाँ पे कुछ भी assume नहीं कर लेना है, ठीक है. जैसे पहले करते थे like a moment about something clockwise we are taking positive, anti-clockwise we are taking positive, so that is for the frame, okay. But here the frictional force, suppose the block A, so block A will try to come down, okay, and the lower block B is here to suppress that with some force. This we wanted to know what is the required force, so that block A should not fall down or should not come down, okay. So that's why the frictional force in block diagram A, this is the block diagram A. So frictional force, it will try to come down, so that's why this is frictional force is taken in upward direction. And similarly here between the blocks, the frictional force is taken just opposite to the this load 500 Newton, this one, see the direction. So this we have to take care. So in this way we have done. Thank you.